You ever pop on your headphones, press play on your favorite song, and just wonder, how does that music actually get from a file on your device into your ears? It feels like magic, but it's really this incredible invisible journey. Today, we're going to follow a single sound wave from beginning to end and uncover the hidden science that makes it all happen.
So let's imagine this. Someone plucks a single guitar string. We're going to trace the path of that one sound, from that tiny little shake all the way through the air, into a microphone, and back out of a speaker. It's a wild ride, and along the way we're going to see just how amazing the invisible world of sound really is.
So, where does any sound begin? I mean any sound, from the quietest whisper to a massive explosion. Well, it all starts with one simple thing: a shake.
That's right, a vibration. That's the secret ingredient. When you pluck a guitar string, you can literally see it wobble back and forth really fast. You hit a drum, the surface shimmies. That rapid back and forth movement is the birth of every sound you've ever heard.
Okay, so the string is shaking over there, but how does that shake get all the way across the room to your ears? This is where it gets really cool. It's like an invisible relay race, a handoff happening between billions of tiny air particles. What's so fascinating is that the air itself doesn't travel. A particle from the guitar doesn't fly into your ear. Nope. Instead, it just bumps into its neighbor, which bumps into its neighbor, and so on and so on. It's exactly like a crowd doing the wave at a stadium. The people stay in their seats, but the energy, the wave, travels all the way around. It's the energy that's making the trip.
Now, there's a sciencey name for this, of course. It's called a longitudinal wave. And it's not like a wave at the beach that goes up and down. Think more like a slinky. You push one end and you see that little compression pulse travel all the way to the other side. The coils just move back and forth. That's a sound wave, a pressure wave, moving through the air.
So we know how sound gets to us, but why are sounds so different? Why does a shout sound nothing like a whisper? It all comes down to two key characteristics: loudness and pitch.
Loudness is all about power. A big, forceful pluck on that guitar string creates a huge vibration. That shoves the air particles a lot harder, which gives you a sound wave with really tall peaks. That height is called amplitude. Big amplitude means a loud sound. Simple as that.
Pitch, on the other hand, is all about speed. A fast vibration, like on a thin guitar string, creates a high-pitched sound. If you looked at that wave, the peaks would be all squished together. That's high frequency. A slow, lazy vibration from a thick bass string, that's a low pitch, and the wave peaks are all spread out. Low frequency.
And we actually measure this speed in something called hertz, which sounds complicated, but it just means vibrations per second. So, you know the musical note A on a piano? What you're hearing is an object vibrating exactly 440 times every single second. Kind of cool, right?
And get this for a mind-blowing fact. We humans can hear frequencies up to about 20,000 hertz, but the greater wax moth, it can hear sounds all the way up to 300,000 hertz. That's literally the most sensitive hearing in the entire animal kingdom. Just incredible.
All right, so our sound wave is zipping through the air. But what if we want to record it? How do we capture it? Well, that's where the microphone comes in to work its magic.
A microphone is a brilliant piece of engineering. When the sound wave hits it, it makes a tiny thin sheet called a diaphragm vibrate, just like your eardrum. That diaphragm is attached to a coil of wire which sits inside a magnet. And here's the magic part. As the coil vibrates back and forth inside that magnetic field, it creates an electrical current that is a perfect copy of the original sound wave.
So really, the best way to think about it is this. A microphone is a tiny electrical generator. It's literally taking the physical energy of the sound wave and converting it into electrical energy.
So we did it. We turned our sound wave into an electrical signal. Now for the final step of the journey. How do we turn it back into a sound that we can actually hear? Well, that's the job of the loudspeaker.
You can think of a loudspeaker as a microphone working in reverse. It's so clever. That electrical signal we just made is sent to another coil of wire, turning it into a temporary magnet. This electromagnet then dances with a permanent magnet, pushing and pulling back and forth at incredible speeds. That moving coil is attached to a cone, kind of like a paper plate, and as it vibrates, it pushes the air, and boom! It perfectly recreates the original sound wave.
So let's recap that incredible journey. It all starts with a physical shake. That shake creates a pressure wave that travels through the air. The size of that wave is its loudness, and the speed of it is its pitch.
A microphone then turns that physical wave into an electrical signal, and a loudspeaker turns that signal right back into a physical wave for our ears to enjoy. It's a journey that happens millions of times a second every time you listen to music.
So we've just unpacked the story of one invisible wave, sound. But it makes you think, doesn't it? What other stories are being told by all the other invisible waves zipping all around us right now? From the light waves that let you see this to the radio waves that bring music through the air. The world is just humming with these amazing journeys. The only question is, which one will you explore next?